Vertex form is basically just, and I need to get my pencil, but it's just, there it is. This form right here is the vertex form. We've been using standard form, okay? It's just another form, a way of writing an equation that is a U shape. That's what we've been doing, okay? Now, if it's in vertex form, you have to pay attention to two parts, the H and the K, because the H and the K represent the vertex, and that also associates with your axis of symmetry. Now, couple things. If it's anything inside of parentheses, a grouping symbol, and I take it out, I have to do the opposite to take it out. Okay? I know this form says minus H, so you can think of it like a negative H. But when I come over here to make the H positive, I need to do the opposite. Okay, so, all right, guys. All right, so if I'm referring, the A refers to your sign being either a positive number or a negative number, okay? And anytime I'm looking at the A, and I'm just gonna highlight this information. So the coefficient, A is our number in front of the parentheses. If it is a negative number, negative sign, negative number, then it reflects the parabola across the X, meaning it's going to open down. Most of our parabolas, or the standard form parabola, is a U shape that opens up. This is, okay. So if this was on the X axis, this would be the X axis right there. Okay, maybe this is my Y axis. And this would be the x-axis here, okay? Maybe this is my y-axis. I'm just saying, positives open up, negatives open down. Talking about the U opening. Do y'all see the difference? Okay, we've been looking at positives. And some of you made that association last week when you did your Desmos and did your matching. Now, the other thing is, if the A is a number greater than 1, this is what's going to happen. This is stating, oops, sorry. This is stating a number greater than 1. We call that a stretch. Basically, this is how you need to know what it will look like. It will look narrow. Okay. We kind of sometimes tend to say that it's going to get skinny. Okay. So parent function is a basic U, but that U is going to get skinnier when it is greater than 1. So add that skinny to your notes. Now, if the A is 0, is less than the absolute value A, I probably should need to just underline right here, which is less than 1. This means a number between 0 and 1, like a fraction or a decimal. Who has an example of a number between 0 and 1? 0.25. That would work. What fraction is that? 1 out of 4. So if I see a fraction or a decimal, then it's going to be compressed, but basically what you need to know how it's going to look. It will look wide. Okay? Do we have those two down? All right, now the H, think of H for horizontal. H for horizontal. The H shifts left or right. Now, just be careful because you got to think opposite. Stop the talking, please. If it's a positive, normally on the number line, positives are to the right on the number line, right? But for horizontal shift, it's going to go to the left. You got to do the opposite of what it's showing. So if H is positive, you move to the left. If H is negative, you're going to move to the right. Do we have that down? H for horizontal. When I'm referring to shifting, I'm talking about shifting left or shifting right or left. Okay. And then your K, the last one here, K is outside the parentheses. K is for a vertical shift. Positive is shifting up, negative is shifting down. Vertical is meaning we're going up or down. We have that filled in. Okay, so we're going to start off with comparing the transformation, the vertex form, to a parent function. So the first key thing right here is we're going to compare to the parent function. The parent function, just draw an arrow to the right here, is y equals x squared. That's what we're going to graph first. To get your calculator in your hand, because even if you forget what the vertex form is, you could be able to put it in the calculator and still get to your answer. Put y equals x squared. I'll wait for you. And we're going to graph this, guys. So you need to see what the graph looks like. Let me clear this out. Let me clear this one out. How do I get the points to the graph?
Trace.
Huh? No, not trace. Not second trace. I want the points on the graph.
Oh, second graph.
Yeah, second graph. Go to the table. Here are your points. Remember, in the table of a quadratic, they should repeat, right? Look at your y values. What happens on the top should happen on the bottom. So do we see 0, 0 is the vertex? We need to plot these points on our actual graph. This is going to be, I'm going to do it in red. You might want to color code. So 0, 0 is 1, 1, and then 2, 4. That gets reflected over the y-axis. We're just basically doing a curve or sketching a line through these points to make our U shape. And this, oops, my curve is off, sorry. Like that. This is our parent function. This is who we are going to compare to each time. That's 2. Did I do 5? I'm sorry. Let me fix this. 2, 1, 2, 3, 4. Yeah, sorry. There it goes. All right, so we have our parabola. It's positive x squared, so it opens up. This is our parent. Okay, so what they want us to do is transformation analysis. Transformation to the new equation, which will be, our new equation is going to be right here. This is the new one we're going to put in to our calculator. All right. Now, when we come up with our transformation analysis, we need to know the A, the H, and the K, and that is from the transformation form, the vertex form. Our vertex form looks like this. A parentheses x minus h, close the parentheses, squared, then plus the k. Okay? So they do want you to see, can you find the parts to the formula? But you can also find it on the graph. So on here, if I line it up, A is before the parentheses. So what's the value of A? 2. Okay. So we write A equals 2. And A, if you go back to the top here, affects it reflecting up or down, and it reflects the size. So because we have a 2, would our sketch become narrow or wide? Yeah, it's going to become narrow, okay? Then we want to look at the H. What is the value of the H? It's actually a positive 1. I know it says -1 right here, -1, but do the opposite when we take it out. And then what is our K? -4. Okay? So this helps me get to the location of our graph if we didn't have the table in our calculator. Because vertex, guys, because It's the opposite of what's inside.
Always?
Yeah, if I take something out of parentheses, I have to do the opposite to take it out. Okay, so vertex, guys, is always the H comma K. So what would be our vertex here? 1 comma -4. Good. Okay, let's go ahead and plot that point. Okay, that's 1 comma -4. So 1 comma, so over to the right one and down 4. And this is where the axis of symmetry is going through. So this is where the vertical line is going to go through that point, which means AOS is the abbreviation for axis of symmetry. The axis of symmetry when vertex form is always x equals h. And our h was -1. So this would be, it was 1. So x equals 1. That's where that vertical line is. I'm just going to write AOS. That's our axis of symmetry. Okay, so we're going to put this equation in our calculator. I want you to type it in. I want you to graph it. Okay, so go to y equals for y2, we're going to do 2 parentheses, then x minus 1, close the parentheses, square it, and we're going to minus 4. Okay.
Oh, we gotta put a new. Oh my God.
Okay. And we're going to graph it. So the blue one for me is my parent. The red one is for my new equation. Okay. So comparing to the original, we know it's opening up. We know it got skinnier, right? Did it horizontal? That's the left or right. Did this equation move to the right or move to the left?
Right.
It went to the right. So the way you check is you check your vertex. You see how this vertex is right here at 0? And this vertex is over here? It would have moved over 1, 2, what is it? Over 1, yeah, over 1 unit. And it would get there, right? So it was a shift to the right. And then it went down, right? Okay, so that's basically what we're describing as our comparison. Now, when we graph this, we have our vertex right here. This is the vertex. But we need some points. Where can I find the points to the graph? Yeah, second graph. Go to the table. Second graph. And our vertex was here at 1, -4. So at 0, we have a -2. And at -1, we have a +4. Do you see that? Excuse me. Let me get reconnected. So let's get these points graphed. Let's make the U shape. Okay, so because I know my A was positive and greater than 1, then that let me know I would had a vertical stretch. Okay, so they want to compare it to the parent function y equals x squared. The graph would be, it's going to be stretched vertically. Okay, so, oops, sorry. Oops. So it is narrow. Now, because we have H is positive, that's our horizontal shift. So the graph is also going to have a horizontal, and I'm going to abbreviate that, HORIZ. Positive is meaning it is a shift actually to the left, to the right. So we have a horizontal shift right, and the H was 1, so it went to the right 1 unit. And then our K is the vertical shift. So we have also a vertical shift down, because K is negative. Down 4 units. And then I realized I put a plus sign, and this actually should be a minus sign right here. because we had a minus right here inside the parentheses. Negative, it's a shift to the right. And if it's negative on the K, it's shift down. So I can physically see that this graph went down to the right here, and then it went down 1, 2, 3, 4 units. So what's our domain? Yep, always all real numbers for parabolas. And our range. Our range has to do with our vertex as being a max or a minimum. Yep, y is greater than or equal to -4. Very good. If it opens up, is greater than, down is negative. All right, so that's what we're going to practice today, is comparing to the parent function and describing the change, the transformation. All right, so yes. All right, so open up to the first graph. So I want you to open up. Open up. Are we okay? You didn't write down the transformation. You have to do that. You're going to have to describe how the graph changed from the parent. Okay, so put the parent first. If you want to highlight that, I'm going to color code to compare. So you're going to compare the red, my red parent to
So what's
the parent function.
Is it x to the power of 2?
It's y equals x squared. That's the parent function for a quadratic. Always. For a quadratic, it's y equals x squared.
And we're always going to use the parent, right?
I'm always comparing to the parent, yes. All right, so that means here's my parent to right here. It's always going to be a parabola with a vertex at 0, 0. And now we're going to compare the new function to this parent. So this is the new function. F of x is the same thing as saying y equals a negative x plus 3 parentheses squared plus 5. It's the same thing. So what is the a value here? Where is the a located? Yeah, it's negative what? -1. What is the h value? No, not 3. -3. What is the k value?
5.
Yep, 5. So what's our vertex?
3.
-3, comma 5. Very good. So I can plot that. That means I'm going to the left.
Like you see the parentheses, right? If you take it out, you automatically switch it. So if it was like +3 is +3, but like this is like yeah.
All right, so we're going to plot this point. -3 means to the left 3. And we're going to go up 5. 1, 2, 3, 4, 5. We're going to plot that vertex. Our axis of symmetry has to go through that point. So it's the vertical equation x equals -3. It's always the x coordinate. So that is our line of reflection, our line of symmetry. Yeah. All right, so use your table, guys. And I didn't put this in the calculator, so I have to put this in here to come up with my points. So we had a negative parentheses x plus 3, close the parentheses, square. Oops, I didn't square it. And then we had plus 5. And we're going to graph it and compare it, right? So how do you think this graph changed?
It's on the left.
Nope. It went to the left. We got to look at the vertex. And it opened down, so that means it became negative. but this vertex actually shifted up. You see, down to the left and then up 3 or up 5, I think. I can't remember. All right, now guys, you're gonna have an ed puzzle to help you finish this. You need a graphing calculator to help as well. So in order for that to happen, you need to either use the Desmos calculator online or the Calculator 84 app. I've mentioned that before. All right, so I'm going to use the table and the vertex to get some more points, because at a negative 3, 5 right here, this is my second equation. I can see the patterns 4, 4, and 1, 1. So I can use that to get the next point. So if I'm at a negative 2, let me go back to the actual picture of our graph. So here we go. So and it's opening now. So if I'm at a negative 2, it's at a positive 4. So 1, 2, 3, 4. So that's right here. And the axis of symmetry allows me to reflect that point. So that's a point on the other side. And then the other thing I had was the y-intercept. I think if it's at 0, I can go back and look at the table. It was also at a negative 4 right there. Boom. Okay. So that allows me to see 0. Oops. Let me fix that. Sorry about that. So at 0, it is at negative 4. 1, 2, 3, 4. And that is 1, 2, 3 units this way. So if I go 1, 2, that's actually going to be off the graph. So I kind of get a shape, an idea of the shape. I can sketch that now. It's going to go through that point, hit that point, hit the vertex, and then turn, and then come down like that. All right, so now I can compare, or kind of compare this graph to the parent function, which is my red function. So if I look at this, well, we know it's opening down. So that means compared to the parent function, the graph will be reflected over the x-axis. That's our A. Whenever we get a negative number, it's going to be a reflection. And then if I look at my H, since it's a negative 3 for my H here, then if I look, here's my original vertex at 0, and it shifted to the left 3. So we're going to have a shift. I'm going to say 3 to the left. And then also vertex goes up, because it went up 5 and then to the left. So then we also have, sorry, it's going to shift up 5 units. So we're going to describe its comparison. So our domain will be all real numbers. And then the range is with our vertex. Now this vertex for our new is on a max. And whenever it opens down, pointing down would be less than. So this is y is less than or equal to 5. So I want you to try number 3 here. And let's just see how well you fill in the parts and you check your understanding. So just kind of pause the video. And if you want, you can start off with your parent function, because we're going to compare it to the parent. Sorry, I got to sketch that. And then we want to put this in our graphing calculator so we can graph it and compare it to it. So I'm going to let you try that. All right, check your answers, your comparisons. And I want you to try number 4. I'll check number 4 in class, and then you can go on to the next part of the video for 5 through 7. All right, thanks.